Welcome class to this video on section 8.1 angles of triangles. In this video I'm going to go over with you how you can complete this handout, which you should have received via Google Classroom, all about the angles of triangles. And to start us off, we're just going to look at the classification of different triangles. Over here on the left we have a scalene triangle. You can see that right here. And a scalene triangle is a triangle that has three sides that are all a different length. Okay, and you can see that in the image there. An isosceles triangle is a triangle that has two sides with the same length, and the third side is a different length. And then also we have an equilateral triangle, in which case all sides have the same length. Okay, and then an acute triangle is all angles are acute. That means they are all less than 90 degrees. So an example of that would be an equilateral triangle where all the angles are actually 60 degrees, as you will learn later on. All of those are less than 90 degrees, so an equilateral triangle would also be an acute triangle. Then we have a right angle triangle. You should be very familiar with this. We use right angle triangles or are dealing with right angle triangles when we do the Pythagorean theorem. And so you can see in a right angle triangle, one of the angles is 90 degrees. And then we have an obtuse triangle, and an obtuse triangle has at least one angle that is greater than 90 degrees, and you can see it's this angle right here. That one is greater than 90 degrees. Okay, so that handles the classification of triangles, and we'll come back to that momentarily as we go forward. All right, classification of angles. So we have a straight angle, and a straight angle always measures exactly 180 degrees. So you can go and fill that in there. A right angle always measures exactly 90 degrees. That's why we call a right angle triangle a right angle triangle, because it has an angle that's 90 degrees. An acute angle is an angle that is, as we discussed above, is less than 90 degrees. An obtuse angle, just like we discussed in this example here, is an angle that is more than 90 degrees. But then it is less than, because once we get to this point, we have a different kind of angle that you should recognize. That's right, it's over here. It's a straight angle. And so an obtuse angle is going to be more than 90, but less than 180 degrees, right? Once it reaches here, it's no longer obtuse, it's just a straight angle. So anything in between 90 and 180 is an obtuse angle. Then we have a reflex angle. And a reflex angle, so it measures between blank and blank. So think about it. Over here, what angle do we have? If we have here this angle here is 180 degrees. Now, however, it's going past 180 degrees. Do you see that? How it's going past 180 degrees? So an angle, a reflex angle measures between 180. And can you guess where it stops? Well, it's going to go it could go all the way around like this, but it's going to stop here. What would that be if we did a full circle? That's right. If we do a full circle, that's 360 degrees. So a reflex angle is going to be between 180 degrees and 360 degrees. All right, moving on, we can now talk about three angle relationships. We can talk about complementary angles, supplementary angles, and opposite angles. And these are going to be very important as we go forward in this unit, especially when we start looking at transversals and parallel lines. So when we have complementary angles, those are two angles whose sum is 90 degrees. Okay, and you can see here, from here to here is 90 degrees. And I have two angles because this line goes in between, right? I have an angle here. I'll use one color for that. And then I have another angle right here. So you can see I have two angles. And if I added up the purple angle and the blue angle, then it would add up to 90 degrees. And then we can call those angles complementary because together they add up to 90 degrees. Supplementary angles. So you can see here, from here to here is a straight angle, which is 180 degrees. And we'll use the different colors again. And so we have a line though here, so we have two angles, and those two angles combined, so this blue angle right here and this purple angle right here, they are going to combine for 180 degrees. Two angles whose sum is 180 degrees. Purple angle plus the blue angle gives us 180. All right, and then opposite angles are the same. Or we could say are equal. Same thing. All right, so let's take a look at a couple of applications of complementary, supplementary, and opposite angles before we move on. As was just stated, complementary angles add up to 90 degrees. What this means is, if I have, as we have in this example here, a set of complementary angles where you know one of the angles but don't know the other angle, you can do some simple arithmetic and find the value of the unknown angle. In this case, we have an angle that we know, which is 62 degrees, and we have an angle which we don't know, which is x. And in order to find x, all we need to do is subtract the known angle from 90 degrees. Okay, so subtract the known angle from 90. So in this case, the known angle, as we said, is 62 degrees. So we can simply write x is equal to 90 subtract 62. And then we would get x is equal to 28 degrees. As noted, supplementary angles add up to 180 degrees. And so just like we did for complementary angles, we can do some simple arithmetic to find out an unknown angle when we know one out of the two supplementary angles. So in this case, these angles y and 77 are supplementary, and in order to find y, I can do some simple arithmetic. In this case, I'm going to subtract the known angle from 180. So the known angle in this case is 77 degrees. So to find y, I'm going to do y is equal to 180 subtract 77. That's going to give me y is equal to 103 degrees. According to opposite angle theorem, vertically opposite angles are equal. So if you take a look at the diagram that you can see on the screen here, in this diagram, there are four angles created by the two intersecting lines. I know the one angle is 145 degrees. Therefore, I can use that to find the angle that is vertically opposite of it, which is x. And that means that x is therefore equal to 145 degrees. This would also mean that angle y and angle z are also equal to one another. The opposite angle theorem is useful because anytime you have intersecting lines, it doesn't matter how you draw them, the angles that are vertically opposite of one another will be equal to each other. So if I made this A, B, C, and D, then A would be equal to B, C would be equal to D. Okay, because those are the angles that are opposite of one another. Now that we've looked at basic angle relationships, we can now look at the interior and exterior angles of triangles. The first rule we're going to look at here is the sum of angles in a triangle theorem. The sum of the interior angles of a triangle is equal to 180 degrees. And so if we have interior angle here, C, A, and B, A plus B plus C is going to equal to 180 degrees. And we're going to pause for a moment here just to look at how we can use this to find unknown angles of triangles. As noted, the sum of interior angles of a triangle is always 180. And so what this means is if I know two of the angles of a triangle and I want to find the third, again I can perform some pretty simple arithmetic to find me the third angle. All I need to do is subtract the two known angles from 180. And it looks like this. A is going to be equal to 180 subtract 65 subtract 75. A is equal to 40 degrees. Some teachers prefer if you were to write it like this. So if we were doing A equals, then they would prefer you do 180 subtract 65 plus 75. And it's the exact same thing. You will end up still with the answer of 40 because you will do your brackets first. And you would get 140, and then 180 subtract 140, you would get 40 degrees. Either way is completely acceptable. Coming back to the handout, we'll now look at equilateral triangles. We have learned that with equilateral triangles, all sides are the same length. And what this also means is that all angles are going to be within the triangle are going to be equal to 60 degrees. With an isosceles triangle, we've learned that there are going to be two sides which are the same length. And what that means for us is that the angles at the base of the isosceles triangle are going to be the same. Okay, so the base of the triangle is this and this right here. Okay, the base of the triangle, those sides are going to be the same. For exterior angle theorem, the exterior angle theorem says that the sum of the two opposite interior angles are going to be equal to the opposite exterior angle. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So if we look in this example here, A and B are opposite to D, and it's the sum of those. That means if I add them, so that means that D is going to be equal to A plus B. And then if we look at exterior angles of a triangle, the exterior angles of a triangle are always going to add up to 360 degrees. Okay, and that is going to actually be true for any polygon, as you will learn as we go forward. All the exterior angles all add up to 360 degrees. Let's take a pause here just to take a look at how we could use the exterior angle theorem. Recall that the exterior angle theorem states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. And so in this example that we can see here, the exterior angle is x, and the interior angles are 50 and 60 degrees. So in this first kind of application of the exterior angle theorem, we're trying to find the exterior angle. And as stated, we know that the sum of these two angles is going to be equal to x. As a result, in order to find x, all we need to do is add the two interior angles. So in this case, x equals 50 plus 60. X is therefore equal to 110 degrees. The other application of the exterior angle theorem would require you to find one of the interior angles. If that's the case, because you know that the two interior angles add up to the opposite exterior angle, then what you would have to do to find the unknown interior angle is subtract the known interior angle from the exterior angle. So think, n plus 38 is equal to 76. Therefore, 76 subtract 38 will be equal to n. And we can write n is equal to 76 minus 38. N is equal to 38 degrees. Just so you can see that again, just so that's clear how that's working, n plus 38 is equal to 76. Now think of your basic algebra. To get n by itself, you would subtract 38 from both sides. N equals 76 minus 38. And you can just write it like this. N equals to 76 minus 38. And you'll get the answer 38 degrees in this case. To finish this video off, I'm just going to do now these 6 examples with you. And I'm going to try to show you the method that you should follow for solving all problems like this. The first thing I always do when solving problems like this is I observe and I take note of what I'm looking at. The second thing is, what do I know about what I'm looking at? And then based on that, I can begin to devise a method for solving a problem. So let's follow that method for the next 6 questions. For question A, I see I have a triangle. What kind of triangle? I have an isosceles triangle. Now, what do I know about isosceles triangles? I know that the base of the angles of a isosceles triangle are the same. That means that this angle here, these two angles are the base. This angle y is going to be equal to the base, the other base, which is 70 degrees. So y is equal to 70 degrees. What else do I know about triangles? I know that they have a sum. The sum of the interior angles is 180. And therefore, to find x, I can just do 180, subtract 70, and I will find the value for x. The sum of the interior angles is 180. I know this angle is 70. I know this angle is 70. So I can just simply subtract both those angles, and I get my answer, which is 40 degrees. Now, some teachers prefer if you write it out like this: 180 subtract 70 plus 70, 180 minus 140 equals 40 degrees. Okay, same thing, both are acceptable. Now if I look at B, B is a little more complicated than A. There are several things I need to take into account here. I have an isosceles triangle, which means the bases are the same. That means x is going to be equal to y. Let's start by writing that out here. I also can observe that I have a right angle triangle. Because of this angle here, it's 90 degrees. I also know that the sum of interior angles is 180. So if I want to find these two unknown bases, what I'm going to do is I'm going to do the 180 degrees, and we'll do it for x, and then we can use the value we get to know what y is. So x is equal to 180 minus the 90 degrees that is being used for this angle here. And then we need to find the two other angles which are equal to each other. And so to do that, we're going to divide by 2. And so we get 90 divided by 2, we get 45 degrees. All right, so that one's a little trickier. Hopefully you're able to follow the logic of that. This is 90 degrees. The other two must also combined be equal to 90 because that would equal 180. So I do 180 subtract the 90 from here. I divide, that gives me the 90, which is the sum of x and y, and then I divide it by 2 to find the value of each. All right, and then for C, this one's a little simpler. In C, I'm looking at a scalene triangle. I know a triangle has the sum of interior angles, which are 180. So to find a missing angle, I do 180 subtract 120 subtract 25, and that gives me an answer of 35 degrees. Looking at question D. In question D, again, we have a triangle. It's a 90 degree, it has a 90 degree angle, so it's a right angle triangle. And we have one exterior angle, which is 140. And this points us to something that's very important. Anytime we have an exterior angle like this created from a polygon, the corresponding interior angle will give us a pair of supplementary angles. The exterior and interior angle will be a supplementary angle, which will be supplementary angles, which means they will equal to 180 degrees. And so I can find y very simply by doing 180 subtract 140, and that gives us 40 degrees. Now there are multiple ways that I could figure out x. One way that I could think of it is exterior angle theorem. So this is 90, and this is 140 over here, and I know that x and 90 have to equal to 140, so I could do 140 subtract 90, and that would give me 50 degrees. The other way I could do x is I could do x is equal to 180 subtract 90 subtract 40, and that would still be equal to 50 degrees. And this one works because the entire triangle has a sum of interior angles of 180. Subtract this angle, which is 90, subtract y, which we learned was 40, and we get 50 degrees. Either way can work there. All right, looking at E. In E, we have an equilateral triangle. We know that the interior angles of equilateral triangles are all 60 degrees. Again, once I have an exterior angle, the corresponding interior angle makes a set of supplementary angles together. So that means to find x, all I need to do is 180 subtract 60, and I get 120 degrees. All right, for F, again, you can see how useful it is to know that the exterior and interior angles that correspond make a set of supplementary angles, because I can use it again here, 180 subtract 48, and that gives us 132 degrees for y. Now I can find x. I could find x in several ways. One thing that I could use is what we learned about exterior angles of a triangle equaling 360. So this angle, and this angle added up equal to 360. And we know this angle now is 132. And so to find x, I can simply do x is equal to 360 subtract 132 subtract 85. And probably going to need a calculator for that. And you're going to get 143 degrees as your angle. All right. And there's multiple ways you could do this one. For example, you could have found this angle here, and then you would know this angle plus that angle is going to give us the value for x. Okay. As I said, sometimes there are multiple ways to answer these questions. All right, so that should get you a good start on being able to do these this set of handouts. Good luck with the work.